little closer. A little closer. Well, I mean, you know. All right.
When do I go? Right now? Okay. What is magma? Magma is molten rock material found within the earth. It generally includes some solid mineral grains and or dissolved gases in addition to the rock melt. Lava is magma that has reached Earth's surface.
How does lava differ from magma? Magma is a general term that refers to any molten rock melt on or beneath Earth's surface. Magmas usually include some solid mineral grains and or dissolved gases in addition to the molten liquid. Lava is a much more restricted term to describe magma extruded on the surface. Thus, all rock melts are magmas, but only those extruded at the surface are lavas.
Ron, make sure you zoom in on the question a little bit so you can see the answer and the answer.
Okay. How does the rate of cooling influence the crystallization process? Slow cooling allows ions time to migrate over relatively great distances, which results in the formation of rather large crystals. On the other hand, when cooling occurs rapidly, the ions quickly lose their motion and readily combine into large numbers of nuclei, and hence a mass of small intergrown crystals.
Describe the three conditions that cause rocks to melt. Melting temperature ranges for silicate rocks are most strongly affected by three factors: total pressure or depth, chemical composition, and fluid pressure, essentially the quantity of water involved in the partial melting process. Melting temperatures increase with increasing pressure and as compositions change from felsic to ultramafic. Increased fluid pressure significantly decreased melting temperature ranges for most silicate rocks. Water released by dehydration of sinking subducted oceanic crustal slabs can move upward and promote partial melting in overlying mantle rocks where temperatures are too low for dry rock melting but high enough for wet rock partial melting.
The classification of igneous rocks is based largely on two criteria. Name these criteria. The two criteria are 1. Texture, which describes shapes, sizes, and arrangements of mineral grains, and 2. Mineral composition.
Openings produced by escaping gases are vesicles. Obsidian exhibits this texture. It's a glassy texture that's not crystalline. The matrix of fine crystals surrounding phenocrysts is porphyritic. Crystals are too small to be seen without a microscope, have an aphanitic texture, a texture characterized by two distinct crystal sizes are porphyritic textures. Minerals that are coarse-grained with crystals of roughly equal sizes have a phaneretic texture, and large crystals exceeding 1 centimeter in diameter are pegmatites.
Why are the crystals in pegmatites so large? Very large silicate mineral grains crystals indicate extremely fast in melt transport of the mineral constituents, atoms, and molecules to growing crystals. We know that pegmatites magmas are small volumes relatively low temperature melts that are extremely rich in water and other dissolved volatile gases. The volatiles promote very fast rates of molecular transfer, thus accounting for rapid growth of very large crystals.
What does a porphyritic texture indicate about an igneous rock? Since crystal size is related to the rate of cooling of magma, two different crystal sizes in the same igneous rock, a porphyritic texture usually indicates two different rates of cooling. For example, a magma begins cooling within Earth and large crystals form, and then the material is erupted onto the surface where the remaining magma cools quickly.
Compare and contrast the following pairs of rocks, granite and borite. Granite consists mainly of quartz, dorite contains virtually no quartz. Both of these rocks are quartz-gained rocks. Basalt and gabbro. They are both basically the same thing. The difference is the gain size of rock. They are both the same composition. Andesite and rhyolite. With other minerals, rhyolite is quartz. They are both fine-grained.
How is tuff differ from other igneous rocks, such as granite and basalt? Tuff is a pyroclastic rock formed from fragments ejected during a volcanic eruption. Granite and basalt are crystalline rocks.
What is the geothermal gradient? General knowledge gained from deep mines and drill holes tells us that rock temperatures gradually increase with depth below a relatively shallow zone, wherein rock temperatures are dominated by circulating groundwaters and surface climatic conditions. The change in rock temperature with increasing depth in the earth is called the geothermal gradient. The average geothermal gradient in stable crustal areas of Earth is approximately 30 degrees Celsius per kilometer.
Describe the three conditions that causes rock to melt. Melting temperature ranges for silicate rocks and are most strongly affected by three factors: total pressure, chemical composition, and fluid pressures. Melting temperatures increase with increasing pressure and composition change from felsic to ultramafic. Increased fluid pressure significantly decrease melting temperature ranges for most silicate rocks. Water released by dehydration of sinking subducted oceanic crystal slabs can move upward and promote partial melting in overlying mantle rocks, where temperatures are too low for dry rock melting but high enough for wet rock partial melting.
What is magmatic differentiation, and how might this process lead to the formation of other different igneous rocks from a single melt? Magmas contain many different chemical constituents. Minerals that crystallize from magma almost always have different compositions from the magma, and during any given portion of the crystallization history, only a fraction of the magma crystallizes into minerals. Physical separation of melt and crystals can produce rocks enriched in the early formed minerals and a magma enriched in those components excluded from the early formed minerals. Rocks different in composition from the original parent magma can then crystallize from remaining compositionally changed magma. This process, known as magmatic differentiation, operates through the crystallization history of a parent magma and later derivative magmas. Thus, accumulations of early formed minerals and crystallization of later stage derivative magmas can result in different igneous rocks being derived from a single batch of an original parent magma.
What is partial melting? Partial melting denotes the fusion behavior of multi-component solids. All rocks are a mixture of minerals of different compositions that melt over a range of temperature. Melt fractions produced at lower temperatures are enriched in the more fissile components, and unmelted residual solids are enriched in refractory components. Just think of the reverse of Bond's reaction. Low temperature, small volume, partial melts of basaltic rocks would be enriched in K and Na, rich feldspar components. At higher temperature, pyroxenes and olivine would be the last minerals to melt. In general, the composition of partial melt fractions are more felsic than the solid parent, and the residual solid rocks are more mafic. partial melt liquid fraction and residual and melted solid fraction are generally different in composition from the parental solid rocks.
How does the composition of a melt produced by partial melting compare with the composition of the parent rock? Do you want me to do that? Sure. Let me know when you're ready. How does the composition of a melt produced by the partial melting compare with the composition of the parent rock? As a generalization, partial melts are enriched in chemical components from minerals with lower melting temperatures ranges and depleted in components from the more refractory minerals. Thus, basalt partial melts are enriched in alkalis and silica and depleted in magnesium compared to the perennial mantle peridotite. Partial melting of mafic rocks in the lower crust is expected to yield more felsic liquids such as andesite and rhyolite, depending on the extent or degree to which of the basaltic parent is melted. The smaller the percentage of the parent rock that melts, the more felsic the derived liquid. Of course, complete melting without any fractionation produces a liquid with the same composition as the solid rock.
What is the difference between granite and diorite? Granite and diorite both are phenolitic igneous rocks. Granite has quartz and potassium feldspar as dominant minerals and is white in color. Diorite has plagioclase, sub-equal amounts of sodium and calcium, and is the definitive mineral and is darker than granite in color. Biotite, hornblende, and augite are ferromagnesian minerals that are commonly found in diorite.
List 2 types of hydrothermal deposits. Hydrothermal solutions can deposit minerals as vein deposits and fractures, or as disseminated deposits distributed as minute masses throughout an entire rock body.
In addition to the rate of cooling, what 2 factors influence the crystallization process? In addition to the rate of cooling, the mineral composition of a magma and the amount of volatile material influence the crystallization process.